part 2 of the 24 volt lead acid battery charger. The transformer is now here, and I made a 230 volt connection, of course with a fuse, always a fuse to the main supply. In this case the fuse is 1 ampere, I think that's enough. And everything is mounted here in a very sturdy way, and the 24 volt transformer is here. And when you make a charger, you always must do an endurance test of your transformer. Charger transformers are normally made in a very sturdy and heavy way, so that they can handle a lot of overload. Of course, all classical old school technology. I don't talk about direct computer power supplies or direct supplies, but this is all old school. And the endurance test is very important, because such a charger must be able to charge that battery for, say, 10 hours or 20 hours. And it may not get too hot. So this is a setup to test this 24 volt transformer, and I found that it could generate 3 ampere at 18 volts. When I connected two 12 volt 50 watt lamps to the transformer, after the bridge rectifier of course. And now I've made the circuit somewhat different. Now the circuit takes 1.5 ampere at 24.5 volts. This is 24.5, now it's 24.8, so 25 volts, that's quite good. In practice the maximum voltage will be below the gas barrier of the 24 volt lead acid battery, so say 28.4 or so. But that means that the current, the charge current, will go somewhat down, but that's not a problem. And this is the whole experimental setup. I've mounted here a 470 microfarad capacitor. It's important to tell that when you make that value of that capacitor higher, say 4700 microfarad, it could be that you get more energy out. Sounds quite strange, but it works that way. The ripple is removed better with a 4700 microfarad capacitor. And that means that the current that will flow into the battery, the lead acid battery, will be somewhat higher. You can test that out, and it will give, in many cases, a substantial effect. Here we read the current now in the circuit, approximately 1.5 DC amperes. And this is the load to 8.2 ohm 20 watt resistors in series, so together say 16 ohms. And of course they are toasted now, and that's the reason why I use here a piece of mesh, a small aluminum plate, to keep these two resistors not too close to the wooden board on my workbench, because otherwise I will see a lot of smoke, because the wood will surely scorch or burn anyway. So this is the test setup You can also use automotive lamps, car lamps for 12 volt, 2 of them in series, and then for instance 2 of these lamps for 20 watt in series. And I think in that case you also will have approximately 1.2 or 1.3 ampere, and such a lamp of course also gets very hot anyway. No problem. Put these lamps for instance on a piece of metal here, for instance, piece of aluminum, piece of zinc, whatever, and then you do that endurance test. Of course always use a fuse in such a test, and if possible cool the bridge rectifier. I didn't do that now, it gets quite hot anyway. This is a good way to do an endurance test. Cooling that rectifier can be done on a cooling plate, a heatsink.